So let's talk about inequality. What comes into your mind when you hear the word inequality? Okay, simply when we talk about inequality, we're talking about expression, mathematical expressions that were put together or at least compared, which happens not to be equal. Okay, so that's inequality. Of course, from the word equality, and then we just add the um, prefix here, which is in, meaning to say not equal or not. So that's what we're talking about not equal, not equal thing, or comparing two quantity or two expressions, how which happens to be not equal. So basically, when we talk about inequality in relation of two real numbers, A and B. So if we have two expression or two numbers, let's say A and B for that matter. So since it's inequality, thus which is this is our symbol for not equal or not inequality, but there is a more specific way of expressing these two real numbers or expressions. Say we have it like A is greater than B. We also may have it as A is less than B. And for this matter here, A is greater than B. This is true if A minus B is positive. Okay? So whenever we subtract B from A is greater than B. That is if the difference of A subtracted with B is positive. But if it's negative, then surely we cannot say that A is greater than B. It should be the other way around. Thus, it follows as A is less than B, it means to say that B here minus A should be positive, but is positive also. Okay? Well, basically, that's what's going on when we talk about inequality. So symbolically, there are actually, this is the basic that we have symbolically for inequality. We have unequal or not equal, greater than, we have less than. We also, of course, have the inequality symbol of greater than or equal to B, and we also have A is less than or equal to B. So basically, this is now being combined that our inequality expresses the idea that a certain value happens to be greater or less than something that includes, I mean, but it welcomes the idea that it is also probably equal to the other value that is being compared. So all in all, we have all the symbols here representing our inequality operation. So we have not equal, greater than, less than, greater than or equal to, less than or equal to. So we have here um, our symbols for inequality. But talking about inequality, there are actually what we call properties of inequalities. What are these properties? Okay, the properties of inequalities. Okay, what are these properties? Let's start with the first one. Who can give me a property of inequality and tell me what is this property all about? Actually, when we talk about addition or when we talk about subtraction property of inequality, it's just being covered with addition property of inequality. In fact, when we talk about properties of inequalities, addition, I mean subtraction and divisions were not encountered or were not considered. It's just that they only have addition and multiplication because of the idea that subtraction and divisions are actually just covered with the two operations such as addition and multiplications. Now, how is that possible? Now, since you mentioned subtraction property of inequality, let's start with addition. Okay, for addition property of inequality, for instance, we have here A, which is uh, A is greater than B, for example. If this is our assumption that we have here variable A that is greater than B, under addition property of inequality, we may have it like A is A plus or minus C is still greater than B plus minus C. So in other words, adding or subtracting the same term to both sides of the inequality or adding the same terms both sides of the inequality will still give us the same would still give us the same inequality equivalent. So what I'm saying here is that whenever you have A is greater than B, so what I'm trying to say here is that whenever we have here A greater than B, so adding the same term to both sides of the inequality, whether that is positive or negative, still the inequality holds. When I say holds, it means to say the inequality never changes or it still in favors to wherever is the original greater value. So for example, that's why I told you adding any terms, whether it's positive or negative, so long as it's both, or so long as you are adding the same term to both sides of the inequality, still the inequality holds or remain. So what I'm saying is that, for instance, let's say you have here a number, um, for example, you are adding, we know for a fact that 5 is greater than 3, right? So if 5 is greater than 3, in the event that we are adding 2 to both sides of inequality, still like you have 5 plus 2, and then you have 3 plus 2. Still, the inequality remains that the side where 5 is still greater than that of the other, which is 3. Okay? So if you look at this one, that is true because of addition property of inequality. Now, the same is also possible if we are adding adding the negative symbol. For instance, that's why I say that subtraction is just covered by addition. For example, you have 5, still 5 is greater than 3. For instance, you have 5 plus negative 2. It's still greater than 3 plus negative 2. May follow? We actually added the same term, but the term that we added to both sides of inequality are negative or is negative. So that happens that as we try to simplify this one, if you look at this one, this is further can be simplified as 5 minus 2 is still greater than 3 minus 2. So it appears that it's like subtraction. See? But actually, the original idea there is that it's still addition. Okay, it still boils down to the concept of addition that we just added a negative term to both sides of the inequality, which the term added was the same, so long as it's the same. Okay, this is true, and this is also true also in have A less than B. The assumption is A is less than B. Still adding the same term to both sides of the inequality, still the inequality holds or remain. Thus, it follows that you have A plus or minus C is still less than B plus minus C. Okay? That is the first property that we are talking about, which is the addition property of inequality. Who has another idea or another property that you can share to the class? Actually, subtraction, there's no such thing as subtraction property of inequality. It's just addition because everything were just added. It's just that what we're adding is the same. What we're adding is the negative terms. Anyway, talking about addition, the second property is actually the multiplication property. Okay, what is this multiplication property of inequality? That's MPE, multiplication property of inequality, MPI. Multiplication property of inequality, it follows that with the assumption that you have A greater than B, it means to say that this is the condition that you have to satisfy. If A is greater than B, and if there is C, okay, and the condition if C is positive, okay, what will happen is that the symbol, the inequality operation remains the same. So it's like saying that if A is greater than B and C is positive, then AC is still greater than BC. That's true. That is if our C, the term added to both sides of the inequality, the term multiplied to both sides of the inequality are both, happens to be positive. So still the inequality remains the same. But in the event that you have the assumption of A greater than B, and we have here a term C, which happens to be negative, well, obviously, what will happen is that A multiplied to C becomes less than B multiplied to C. That is if our C here is negative. Now let's try to look at this one closer using our example. Let's say, for example, you have 5 greater than, of course, 5 is greater than 3. Now, in the event that we multiply 5 and 3 with the same term that is positive, let's say, for example, 5 multiplied with 2, is it? And then you have 3 multiplied with positive 2. Still, the inequality symbol remains as 5 times 2 is still greater than 3 times 2. But in the event that we have it like this, the second one, of course, 5 is greater than 3. But if our number, or the number that will be multiplied to both sides of the inequality is negative, as explained to the second instance under multiplication property of inequality, let's say, for example, you have 5 times negative 2 is now then less than 3 negative 2. Obviously, it's because if in here this is 10, and then of course this is 6. Of course, 10 is greater than 6. But if in the case here below, this is negative 10, and then you have 3, this is negative 6. Obviously, comparing negative numbers, the smaller the number is, it's greater than bigger numbers when it is negative. Okay? So obviously, applying multiplication for inequality, the moment you multiply negative numbers to both sides of the inequality, the same number, of course, the symbol reverses, or the inequality operation reverses. Instead of it is greater than, it will become less than, or vice versa, whatever is your inequality operations involved. So that is our second property, which is the multiplication property of inequality. So we did have already multiplication and then addition property of inequality. Now let's talk about another operation, or rather another property of inequality. Let's say we have now the third one, which is the trichotomy. Trichotomy. Okay. We have the so-called trichotomy property. What is this trichotomy property? Who has an idea what is this property all about? From the word tri, and of course, so it means to say now, when we talk about inequality, there is just one thing true about true for the 3 instances. So what I'm saying is that if for trichotomy property, for real number, for example, for real number, so I'm talking about now here the real numbers. For real number, A and B, one thing is only one is true for them. Okay? For real number A and B, exactly one of the following is true. So either A is greater than B, you have, or A is less than B, and lastly, A equals B. So one of these is true for A and B. It cannot be two of these happens to be true. That's impossible. So when we're talking about A and B here, it's either A is greater than B, or A is less than B, or they're equal. Okay? You cannot say that A is greater than B, at the same time, A is less than B. That's impossible. That's according to the trichotomy property. So for any real number, for that matter, one of these is true for them. Okay? So it's either A is greater than B, or A is less than B. Otherwise, they are equal. That's according to trichotomy property. Okay? The next property that we have is, okay, I'm sorry. There is division property. Division property somehow was emphasized for inequality. It's because of the idea that we might have, the ruling here is that there is an additional condition that the denominator cannot be 0. Anyway, so for division, but was inequality, I'm not sure. For division, if we have A greater than B, see, the same with multiplication, if C is positive, okay, we have here if A is greater than B, and then if A is greater than B and C is positive, then A over B is still greater than B over C. Okay? That is according to division property of inequality. It follows that if also A is less than B and C this time is negative, the symbol of inequality reverses. Okay? It will reverse this time. So what will happen is that if this is the case and then we are actually dividing negative number to bosses of the inequality, what will happen is that you will have A divided by C and B divided by C. In the event that A is less than B and C here is negative, what will happen is that the symbol of inequality reverses. Okay, it will reverse. It's because of the negative numbers. The same with the idea in multiplying negative numbers. So we divide both sides of inequality with the same number. But in the event that we're dividing negative numbers to both sides of inequality, what will happen is that the symbol of inequality reverses. It will go the other way. Okay, and unlike addition, that the symbol of inequality remains the same. But we have to have here the assumption that in division, C, for these examples that we have, C here can never be 0. Or at least C must not equal to 0. Why? Because I don't know if you're fully aware of this one, but in our earlier days, we were taught, if I'm going to ask you, what is 0 divided by 1? Monte Calvo. This is the second time I called your name. I'm not sure if you're with us or it's just that you just let your account join the class, but you're not actually with us. I don't know what's really the truth. Tumaldos, what is 0 divided by 1?
0.
And what about 1 divided by 0?
0.
What about 0 divided by 0?
0.
Actually, among the three answers you gave me, only one there is correct. 0 divided by 1 is definitely uh, 0. Okay? That is following a certain property. But whenever you have 1 divided by 0, 1 divided by 0 is, it's like, how am I going to explain that? If you have 0 divided by 1, applying multiplication, property of multiplication here, how am I going to explain? I mean, by property wise, 0 divided by any number is 0, that's property wise. But when it comes to any number divided by 0, that's actually undefined. Wait. Any number divided by 0, the result is undefined. Or if it's in the calculator, you will encounter its error, mathematical error. It's because there is no equivalent statement that would help you look for an equivalent whenever a number is divided by 0. That's why it's called undefined. Okay? So that's why I'm telling you here the condition that C can never be 0 if we have the instance of dividing C to any, divide C from the expressions we have here for inequality. Because if C is 0, then we will fall on the concept or the idea of undefined. But basically, there is no such thing. You can never find any equivalent to any expression that is divided by 0. I hope you've learned that today that any number divided by 0 is not 0. which we all know from the past that any number divided by zero is zero. Correct? I think that's the basic math that we all learn when we were still in elementary. But the truth of the matter is that when we have numbers divided by zero, any number for that matter, it's actually undefined. Much more with zero divided by zero. Property wise, if we are going to look at the one, zero divided by zero is actually indeterminate. That can never be determined. I don't know if you have with you your calculator. You try to you try to input any number divided by zero. What's the result?
Error, sir.
See? But if you have zero divided by any number, the result is zero. You try zero divided by zero. That's still error. See? What we all know before, you must have to already change that one because actually those were the the oldest mistake that we've been doing in math. We all learned that. I'm sure that it's not only Mr. Waldo's here who have the same answer when I asked that question. Probably most, if not all, have also the same answer. That any number divided by zero is still zero, as zero divided by zero is still zero. Okay, but please do me a favor and correct that knowledge that any number divided by zero is undefined. Much more with any number or zero divided by zero is not zero but rather indeterminate. Okay, so let's for the segue, let's move to the next property. The next property that we have is the exponential. So what is this exponential? This is the property applied whenever we apply exponent to our inequality. Let's say, for example, if A is greater than B, and then we have C is positive. Now take note of this. This is property. So this is when we say property, this is what governs whenever we talk inequality. So for example, if we have A greater than B and we have C here, another number who happens to be positive. So what will happen now is that um, A raised to C is still greater than B raised to C. Okay? As our exponent is positive. For instance, if 5 greater than 3, it follows that if we have 5 raised to positive 2, it's still greater than 3 raised to positive 2. Okay? It follows that the number here becomes bigger as this is 25 versus 9. But in the event that if we have A greater than B and C here is negative, now what will happen negative? What will happen? So what will happen now is that you have C raised to C, A raised to C, which is negative. Instead of A greater than B, the result, the symbol of inequality reverses. Why? It's because the idea here, we do exponent and then the exponent is negative. The actual rule is like this. When we have A raised to negative 1, for example, and then we have B raised to negative 1. So, originally, if we have A greater than B, but if we raise A to negative 1, the symbol of inequality reverses. Why? It's because the whole concept of this one, I'll just use a certain number so at least you can imagine clearly or you can see clearly why it's so. So let's say as 5 is greater than 3, for example, but if we will raise 5 to negative 1, for instance, and then we have 3 also raised to negative 1, the equivalent of this expression here, this is no longer true. It's because the moment you raise any number to a negative exponent, the actual equivalent of that is 1 over 5, as this is 1 over 3. Okay? The symbol, 1 over 3. And we know for a fact that comparing expressions like this one, this is less than 1/3, or 1/5 is less than 1/3. Okay, this is true because of the so-called exponential property of inequality, that whenever we have inequality, that whenever we have inequality and we apply negative exponent to our inequality, the symbol of inequality reverses. That is according to exponential property of inequality. Any question? Any question? I just really noticed that people from this class are not really attending classes. And to consider that many from this class actually uh, happens to almost fail if only I did not lower the standard for the class. See, I only have 25 students, and I know this class have more than 25 students. Let's see. I'll just, anyway, attendance were all recorded for conference session. As the time you joined, the time you move out, the time you were kicked out, were all recorded. So I just hope so. No one's going to blame me. Because I think perhaps others will just wait for the recorded video for the lesson. That is if they're waiting for the recorded video or they're just taking things for granted. Because they thought this is just a minor subject. Okay, then let it be. Now, let's move to the types of inequality. There are two types of inequality. What are these two types of inequality? First is we have the absolute inequality, and then we have the second one is the conditional. What's the difference, or what is absolute inequality? Absolute inequality, it is a condition where the inequality is true for all values of the unknown involved. So for example, absolute inequality, this is a situation wherein the inequality remains as is for all values of the unknown involved, or for the unknown that we have. So let's say, for example, an equality of x squared plus 4 is greater than 0. Now, this is an absolute inequality because for whatever value of x here, for all values of x, the inequality remains the same. That this side here, an expression x squared plus 4 is always going to be greater than 0. Okay? That is called an example of absolute inequality. Now, going back to the idea here, can someone give me another example of an absolute inequality? So the idea of absolute inequality is that the inequality is true for whatever value of your variable or for whatever value of the variables involved. Who can give me another example of absolute inequality? If we're going to look at this one, x squared plus 4 is greater than 0. How do we justify the fact that this is going to be true in whatever form or whatever value of x? Now let's look at this one. If we try to simplify this, x squared plus 4 greater than 0. If we're going to simplify this further, this is going to be x squared is greater than negative 4. As we move the value here to the other side, that becomes negative 4. And we know for a fact that any number squared is always going to be greater than negative 4 because of the exponent here, 2. So regardless whether your value is positive or negative, it will never be negative because of the exponent 2. So for example, for positive and negative number, value of x, it's always going to be greater than negative 4. Let's say, for instance, you use x equals 0. So 0 squared is simply greater than negative 4. If it's positive 1 squared is still positive 1 greater than negative 4. If it's negative 1, for example, because you wanted to try negative, negative 1 squared is still positive 1, still greater than positive or negative 4. So this is an example of an absolute inequality. Regardless of the value of your variable or the unknown, still the inequality remains true. Okay? Now, obviously, if that's the case for the absolute, meaning to say always, that's the exact opposite is the conditional. Conditional happens when the value of inequality is true only for certain condition, only for certain rule. But beyond that, the inequality is no longer, well, the inequality will no longer hold. Okay? So let's say, for example, in the event that we have this expression, 2x minus 7 greater than, let's say, sorry, let's have 2x minus 5 is greater than 7. If our inequality is given this form, we know for a fact that for any value of x here, there is only certain, like, there's only certain values of x assigned to x that will make this inequality true. But beyond that, this is no longer true. That an expression of 2x minus 5 is greater than 7. How is that even possible? Now, if I'm gonna, we'll just look at this one. Let's set what are the things that we can do. Let's assign number for x. Let's say x equals 0 for that matter. So we have 2 times 0 minus 5 is greater than 7. We know that this is negative 5, and with negative 5 greater than 7, this is false. Okay? This is not true, that negative 5 is greater than 7. So thus, you know that negative or x equals 0 for the value of 0 for this unknown here is not one of the many possible solutions of this inequality. We call them solution. Okay? Solution simply refers to any value of the unknown that will make the inequality true. Okay? So thus, otherwise, it's not a solution. So what I'm trying to say here that conditional inequality simply refers to refers to any value of the unknown that would only satisfy the inequality, or that would suffice the condition. The condition here is that the expression 2x minus 5 is greater than 7. Thus, for a certain value of x, we're only looking for values of x that would only suffice this inequality or this ruling. Beyond that, they're no longer part of the solution. That's why it's called conditional. Inequality is true only for certain condition. Now, how do we know, or how do we set the condition that would make our inequality true if it's conditional? So this is what how we're going, because we know for a fact that x equals 0 here is not true, or it's not a solution of our conditional inequality. What about if we will assign here x equals, let's say, 5, for example. So that's going to be 2 times 5 minus 5 is greater than 7. This is 10 minus 5 greater than 7. This is 5. Still, the answer is no, because negative or 5 is never greater than 7. So see, we tested 0 and 5, and it's not making sense at all. So what about if we will try x equals 6, for example? So that's going to be 2. Then you have 5 minus 5 greater than 7. So this is going to be, sorry, this is 6. So that's 12 minus 5 greater than 7, which is 7 greater than 7. Of course, it doesn't make sense that 7 is greater than 7, for in fact, they're just equal. So it doesn't make sense at all. No. So we will try, of course, 7. So you have 2 times 7 minus 5 greater than 7. Then you have here 14 minus 5 greater than 7, which is 9 greater than 7. See? This time now, it makes sense that when our unknown variable is at 7, the inequality, the condition were now satisfied. That expression 2x minus 5 is greater than 7. But for the values of x, 0, 5, and 6, among others, the conditions were never met. So, how do we know, or how do we set the condition, or how do we identify the values of our conditional inequality, or the values of the unknown for the inequality, the conditional inequality to hold, or to be true, or to be satisfied? So what we're going to do here is that to look for the certain value of the unknown such that the condition of our conditional inequality will be met. So we will now have it 2x minus 5 greater than 7. You try to imagine that inequality, you just disregard inequality and try to consider this as equal. So what we're going to do, we will look for the value of x. So we will move the x here, or we'll move the constant term to the other side. So we'll have 2x greater than 7 plus 5. So which is 2x greater than, this is 12, divided by 2. Take note, we are not trying to apply here the symbol of inequality, the properties of inequality. Actually, what is applied in this solution here is the addition property of inequality and at the same time the division property of inequality. See? Later I will explain what were or how did we apply the two properties. But let's finish first this one. We have x greater than 6. So this is the condition that must be met for the values of the unknown here, such that this conditional inequality, the condition will be met so that this expression here, the left side, the half percent greater than the other side. Otherwise, we're not making any sense at all. So therefore, for x here, the variable x cannot be less than 6. It should be greater than 6, not even 6 at all. Okay? Such that this is going to be true. I said earlier that we applied two properties of inequalities. How did we apply the two properties? Like I said, we applied addition and division. Now you have to look at this one. First is you have 2x minus 5 greater than 7. The first property is the addition property of inequality API, addition property of inequality. How did we apply that? It's like this, 2x minus 5. Actually, the idea of moving the 5 here to the opposite sides of the inequality, changing its operation to positive from negative, it's not actually transposed. The common term that we know is transposed. And we were taught before that whenever we transpose term, move it to the opposite side, the symbol, the sign changes. Actually, that was the shortcut way of telling it. But the idea there, the truth is, we applied property. For inequality, at least, we applied addition property of inequality. How is that even possible? Now, let's look at this. What we did here is we add positive 5. Then 7 plus 5. We added positive 5 to both sides of the inequality. According to the addition property of inequality, adding the same term to both sides of the inequality does not change the inequality symbol. That's why the inequality symbol remain the same. Okay? And then since I added the same term to both sides of the inequality, I did not violate anything at all. So 2x minus 5 plus 5, this is going to be 0. That's why what's left here is x greater than 12. That's how the addition property of inequality were applied. Next is the division property of inequality, the DPI. How is that applied in this case? Now take note, we would like to isolate and look for the value of x. Now we divide this one by 2, both sides, so that the coefficient of our variable x becomes 1, because that's the goal for us to look for the value of x. Take note, according to the division property of inequality, when we are dividing the inequality both sides with positive number, the same term which is positive, the inequality symbol remains the same. No wonder that the result of this is x greater than 6. See, our inequality symbol did not change at all. It's because we actually divide both sides of inequality by positive number, which is the same number, by the way. So, like I said, we applied addition property of inequality and division property of inequality in our solution. But of course, in the real sense, we don't actually emphasize this one. They were just the underlying reasons why we're allowed to do so. But mostly, people tend to forget the real reason why that's allowed. They just simply justify the fact that because that's how we do it. It's not how we do it. We were actually supported by certain properties that actually allows us to do it. Let's move to linear inequality. What is this linear inequality? Now, from the word linear, we're gonna associate now our inequality to a straight line. How do we do the linear inequality? Okay, for linear inequality, there are the steps are we simply will graph the inequality. What are the steps to graphing linear inequality? Is that first is that we will try to deal the inequality as equation. Okay, we look for solutions at least two solutions, because for linear, for drawing a straight line, we just need 2 points, connect the 2 points, and then we will have the line. Okay? Let's say, for example, okay, the first step we're going to do is suggestion. We will change the inequality sign to equal sign, and then we will solve for the value of x. So that we will have now let's take this for example, the first inequality we have 2x plus 5, or minus 5 rather, greater than 7. Let's say we will graph this one. First step is we will replace our inequality symbol with equality. So you have 2x minus 5 equals 7. Now we'll look for the solution or value of x. So for example, okay, so we will have here x, so that is going to be 2x equals 12 divided by 2 divided by 2, you have x equals 6. So one solution here is we have 6. Now, by the way, this is actually an example of a single variable. So whenever this is graphed, this is actually called an intercept, which is the value of x when y is 0. So simply, one of the solution here is that whenever we graph cases like this one, x equals 0, it means to say that the value of x remains the same regardless of whatever is our solution. So if we're going to graph this one, the graph would appears to be this way. 1, 2, 3, 4, 5, 6, 1, 2, 3, 1, 2, 3, 1, 2, 3. Positive 1, 2, 3, 4, 5, 6. Negative 1, negative 2, negative 1, negative 2, positive 1, positive 2. Okay, to graph this one, the implication of equations, inequalities like this, the value of x, since x equals 6, x is true all the way. So whenever you have this one, this is called an x-intercept. The implication of this is the coordinate of this is 0, or rather 6, 0, the coordinate. So which is referring to this one. Since this is x equals constant value of x, then that means to say all the way, we will make a straight line from this point onward, where x is 6 always. So for example, so we will now draw the line here. Okay, we have drawn now the straight line. Why did I use a broken line? Now there is a ruling that is this. For symbols like this, we will use a broken or dash lines, implying that the line itself is not part of the solution. Or meaning to say, if you're going to pick any value somewhere here and plug into our inequality, it doesn't justify or doesn't give us the answer. On the other hand, when our symbol of inequality is this one, greater than or equal to, then we will use a solid line, implying that the line itself, any value that is within the line or on the line, is considered solution or will make sense once applied to our inequality. Okay? So for this inequality here, this is its graph. I use a broken line. It's because of my symbol of inequality, which means that both sides, the line itself is not part of the solution. Okay? It's the boundary, but it's not part of the solution. The next thing that we're going to do is we will identify the solution. Identify the solution. This time, we know that when we have inequality, we're just simply looking for a certain boundary, and then we will look for a bigger answers for that one. In other words, there is no single answer here, but there's a bunch of answers. Possible solution, meaning to say, possible values that will satisfy the inequality. So for us to represent that, we're just going to show the solution set in terms of region. Now you notice our Cartesian plane here was actually subdivided into two regions. We have that region there, and we have this region. Now we're just going to identify which of the two regions is actually the solution. Meaning to say, which of the region there and which between the region there and here is going to make sense once the value were picked and substituted here. that will make this conditional inequality true. So what we're going to do is that we will actually do testing. We will do tests. First, what you're going to do is you'll just pick. Step one is pick number or coordinate or solution, either that direction there or here, and then we will test it to our inequality. If it satisfies, then that means to say the solution set fall on that region. Okay, again, what we need to do is we will pick value or ordered pair, whether from this region or that region, and then substitute it here or plug it to our inequality. If it satisfies or if the conditions were met, then the solution falls on that region. Otherwise, as on the opposite side. So the easiest way to do that is we are going to pick this area. We will use the origin. Why? Because the origin is the easiest number that is there available for us to use. For example, this coordinate here is represented by 0, 0 as known as the origin. Now, in this case, let's test our inequality. So that's 2x minus 5 greater than 7. Our x equals 0 according to this test point. We call it as test point. Test point. Now our test point is the origin, which is given to us as 0, 0. In this case, this is the x, this is the y. Now we will plug in the value of x since our inequality here involves only x. So that means to say you have 2 times 0 minus 5 greater than 7. This is going to be negative 5 greater than 7. We know that negative 5 greater than 7 is false, or it's not true. It means to say this test point here is not one of the solution. So we have here region 1 to the left of the dashed line, which is the graph, the linear inequality of this given inequality, and then that side there is the right one. So what we're going to do is we will shade this region. Okay, this shaded region implies that any value that is picked from this side will going to make or satisfy this one, except that this side here is not a solution. Now let's try to test. If I'm going to extend this one, there are values here. Let's say this is 13, for example. So if we will pick this value 13, the coordinate here is 13, 0. Okay, as it is found on the horizontal line. So if we will test this one, that's 2x minus 5 greater than 7. As our coordinate, this is x, y. Our x is 13, so x equals 13. We're trying to verify now that indeed that side there is our solution. So we have 2 times 13 minus 5 greater than 7. 2 times 13, 26, minus 5 greater than 7. So we have now 21 greater than 7. It makes sense that 21 is greater than 7. Thus, that side there, even if we will test more numbers there, it will be a solution. Now, let's justify why broken line. And I said that broken line there implies that the line itself is not part of the solution. If we are going to pick this value, which is part of the broken line, so that is 0 or that is 6, 0, x and y. We solved it already earlier that when x is 0, when x is at 6, the inequality does not make sense. Let's just try. So you have 2 times 6 minus 5 greater than 7, which is 12 minus 5 greater than 7, which is 6, or rather 7 greater than 7. We know that this is not true, that 7 is greater than 7. That's why the line is broken, implying that the line itself is not part of the solution. Now let's have one more example. We have 2x plus y is greater than 16, for example. Now what we're going to do is we will show the linear inequality of this, we'll show the graph of this linear inequality. So first step is step 1, approach this one like equation. So that's 2x plus y equals 16. Now, after which is we are going to look for two solutions that will make this inequality true. Actually, when it comes to equation, there are several. There are, I think, three or more means to look for at least two solutions to graph this equation, as we're now having equation. So anyway, what I'm going to use here is just using the intercepts. Intercepts, because I think whole number is just possible. I'm going to use intercepts. Intercepts are simply the coordinates where the line of this equation touches the x and the horizontal and the vertical line in our Cartesian plane. So what I'm going to do here is I'm going to look for the value of y when x is 0, and I'm going to look for the value of y when, no, well, I'm going to look for the value of y when is at 0, and I'm going to look for the value of x when y is at 0. So first solution is that y equals 0. When y is at 0, what must be my x? So that is 2x plus 0 equals 16. Then I have 2x equals 16. 2 divided by 2, that is x equals 8. So one of my solution is that I have 8, 0. This is called my x-intercept. X-intercept. It means to say that at this coordinate, my this equation, this line, crosses the x-axis or the horizontal line at this coordinate. Okay. Next is I'm gonna set now look for my y-intercept. So x equals 0. I'm gonna set now x equals 0, and I'm going to solve for y. So that's 2x plus y equals 16. So that is 2 times 0 plus y equals 16. So I have now y equals 16. So at this coordinate, the coordinate for this one is 0, 16. This is called the y-intercept. It follows that the graph now crosses the vertical line at this coordinate. So I have now two solid points. I mean, the two solutions identified, and I can graph already my inequality. Okay, so 2, 4, 6, 8, 10, 12, 14, 16, 18. Negative 1, negative 2, 4, negative 2, negative 4. Okay, first is I'm gonna plot my, oh, my bad, my bad. I should have 6, 18, 16 for the y-intercept. It's the x-intercept that I made it. 6, 8, 10, 12, 14, 16. 6, 8, 12, 14, 16, 18. Okay, so what I'm going to do is I'm going to plot my y-intercept. Again, this is y-intercept, so that means to say the value of y when x is 0. So this is the y-intercept. This is 0, 16, the coordinate. And then my x-intercept is 8, 0. So this one, that is 8, 0. That is the x-intercept. I'm going to connect this one. Then I use arrow both sides. It's because implying that this goes to infinity. It can be extended and does not only end here. Okay, I have now my coordinates and I have already my graph. But since my symbol of inequality is just this one, so I still use broken line, implying that the line itself is not a solution. So it means to say now 8, 8, 8, 0 and 6, 16, 0, 16 are both not a solution of this one. Let's try investigating. So let's pick that one, 8 equal 8 and 0. They are on the line, which the line is broken. It means to say 8, 0 is not part of the solution. Now let's justify. That's 2 times 8 plus y is greater than 16. Our y is 0. So this is 16 plus 0 greater than 16. You have 16 greater than 16. It doesn't make sense as 16 is greater than 16. That's why it is not part of the solution. If we will try also this one, which is 0, 16, 0, 16. So that's going to be 2, 0 plus 16 greater than 16. So that is 16 greater than 16 still. That is not true. So that's why the line or the values on the line are both not a solution. Okay. Now again, we already identified our in our Cartesian plane. We already have the graph. Now let's look at where is the solution falls on. Is it on this region? Let's say this is region 1 and then this is region 2. So where does the solution fall? Is it on region 2 or region 1? Now what we're going to do is we'll do the get the test point. Again, the easiest test point that we can pick is the origin, the 0, 0 coordinate, which is this one, which found in region 1. So let's see whether region 1 is the solution or or the solution set or the solution set found in region 2. So let's test now. That's 2x plus y is greater than 16. So that is 2 times 0 plus 0 greater than 16. Obviously, this is 0 greater than 16, which is not true. So it means to say now that our solution set does not lie on region, does not lie on this region, but it lies on the opposite, which is, this is what we're going to shade. So the shaded region now implies that any points here, for that matter, once plugged into our inequality, it makes sense. Now let's try for investigation's sake. Let's pick this coordinate. Estimated, what is the value of this coordinate? That is, our x here is 12 as estimated, and then our y is also 12. So at 12, 12. Let's test 12, 12 since 12, 12 is found to be one of the solution of our inequality. Let's prove. We have 2. Our point there is 12, 12. X is 12, y is 12. So you have 2 times 12 plus 12 greater than 16. That is 24 plus 12 greater than 16. So you have 24, that's 36 greater than 16. It makes sense that 36 is greater than 16. No wonder that that side there, 12, 12 is one of the infinitely many solutions there is for this. There are for our inequality 2x plus y greater than 16. I'll give you one exercise. This one. You try to solve this one, and I'm going to call randomly somebody to show his or her solution on the screen or on cam so that we will know whether your answer is correct. X plus 2y is greater than or equal to 8. Take note, my symbol of inequality. Go ahead. You have 3 minutes. Show us the graph. Show us the solution set. So show us this one. And of course, you have to show also the entire solution. Go ahead. Who has the answer? Just raise your hand. But after 4 minutes, 4 to 5 minutes, I'm going to call somebody in random if no one's going to volunteer.
Sakto, sir.
No, yeah, that's how perhaps the graph would look like. But where is the shaded region? Above or below the line?
Wait.
Okay, anyway, the answer I suppose is already correct. I'll just quickly gonna show you the solution for this one for everybody's reference. Okay, I'll show the solution for this one, and then you can just go verify your answer, Mr. Waldos, if you did it correctly. Okay, what we need to do first is make this equation x plus 2y greater than or equal to, equals 8. And then I'm gonna look for at least 2 solutions by using x and y intercept. So this is going to be x equals 0. So my y now is 0 plus 2y equals 8 divided by, that's 2y equals 8 divided by 2. That's y equals 4. Thus I have 0, 4 as my y intercept. Okay, and then next is I'm going to have x or y equals 0. So that's going to be x plus 2 times 0 equals 8. So I have x equals 8, giving now 8 and 4, 8, 0 as my y intercept, x intercept. So with this value, I'm going to graph it now. So I have my x is 8, 1, 2, 4, 6. 2, 4, 6, 8. Then I have 2, 4, 6, 2, 4, 6, -2, -2. Okay, plotting now my intercept. 0, 4 is my y-intercept. This is my y-intercept. That is 0, 4. And then my x-intercept is this one. This is 8, 0. Then connect the dot. Now this time I'm going to use a solid line. It's because of my symbol of inequality. Please pardon with my line. Okay. So I'm using actually a solid line here because of my symbol of inequality. It implies that the line itself are part of the solution. In other words, 80 and 04 are both solutions of inequality. Now, the next thing that I'm going to do is I'm going to have now my test point to know whether the solution fall in this line or this region or falls in this region. So that's going to be 0, 0, 0 is it going to make sense with this one? Let's say 0 plus 2 times 0 is greater than or equal to 8. So this 0 greater than or equal to 8, it doesn't make sense. So it means to say that this is the 0, 0 coordinate, 0, 0. So it means to say that this part here is not the solution. Thus, the solution falls on this side here of the line. So from this line, from the line itself, going upward, they are all the solution of our inequality. Okay? So again, from this point here, from the line onward, are all the solution of this given inequality.